Hello everyone. In this example, we will go to see how we can solve internal forces and displacement at node A by using a flexibility method. So let's start. The first of all, we should check the structure if it's determined or indeterminate. So by use this equation m plus r minus 2j. M is the number of members. We have 6 members. Plus R, we have 3 reactions because here in this joint we have 2 horizontal and vertical, and on the roller we have 1, so the total is 3 reactions. Minus 2j. J is the number of joints. We have 4 equal 1. So we have 1 degree. That's mean the structure is indeterminate, and also we should release one part of the structure. So here at node A, this is the node A, we have 2 forces applied on node A. So we should substitute 1 kilonewton for each values of forces we have. This is from theory of structure, and solve the question depends on 1 kilonewton for each one. And also we have for indeterminate structure, you should use another system. So that let me to show you by drawing. This is our structure. The first force is 0.5 kilonewton. So we will remove it and we will put 1 kilonewton plus remove this. Let me to make it clear. Remove the 1 kilonewton and put it 1 kilonewton. This is assumed, okay? And you can make it a hind line because I already moved this part, the F. Also, you can do for the first part, make it a hind line, okay? Because I already released. Plus, you can remove the member number AE. Is up to you, but for me actually I will remove the F. This is called R system. That's mean the TR or TR system. The other part is when I release this member F, I should substitute the force equal 1 kilonewton. Here 1 kilonewton and here 1 kilonewton. And I call this part is X system. Okay. So next we will go to solve the first drawing, this one, the first one, and then I will solve this one, second, and this X system 3. So let's start with the first shape. Don't forget the hind line, and this is 1 kilonewton. Okay, so and this is the reactions. I'm very sorry, I don't have enough space, so forgive me for this mistake or this issue. So let's start. First, we use summation f h equals 0. HA, that means this one, the horizontal, on the, or I can use the number 1, because this is not, because I already put it, this one is the node A, but it's okay, no problem. This is node number 2, 3, and 4. Okay, and this is VA and VB, the vertical force for B node. Okay, plus 1 equals 0 because I don't have any others horizontal forces or reactions. So HA equal minus 1. Then summation moment around B, this one is B, the node 4, okay, equal 0. VA times 3 plus 1 times 4 equals 0. VA equal minus 4 over 3 equal minus 1.33. Okay, so VA equal minus 1.33. Next, actually it's already VB is equal 1.33 positive. This one is positive. It's already to make it equilibrium. Both of them it will be equal 0. Why? Because we don't have any applied force in this shape. I'm talking on this figure. We don't have any forces by vertical direction. Only the two vertical reactions, VA and VB. So when you summation these reactions, you will get 0 because you don't have any applied load by vertical direction. So next, to find internal forces, node number 1, node number 1, this is because minus we have 1 HA, this is N14. Okay, this is 1 not 1 2 and here 1.33. so summation FH equals 0, N14 minus 1 equals 0, so N14 equal 1. Summation vertical forces equals 0, N12 minus 1.33 equals 0, N12 equal 1.33. Okay, so I find the values of N12 and N14, the internal forces for joint or node number 1. So next, node number 2. Node number 2, we have 3 parts connect by each other in then at node A, and also we have applied load 1 kilonewton. Here N23, N24. Here already I got the value is 1.33. and here we have the angle alpha or theta, up to you. Because we have inclines, so should take tan theta or tan alpha, sorry, because I already written the alpha, equal 3/4 equal 36.87. Then make summation fh equals 0, n to 3 plus 1 plus n to 4 times sine theta equals 0. So here we have two unknown forces, then go to summation fv equals 0. 1.33 plus 124, the node 24, cosine alpha equals 0, n 24 equal minus 1.67. Okay, then substitute in this equation. In this equation you will get the n to 3 equal 0, 1 minus 1 after substitute equal 0. Okay, so the other part is already 0. Let's go back to the figure. So I find this one and this one and this one. The others part, others members equal 0 because we don't have any applied forces, and it's look like empty. You can check by your own, and I believe you will get 0. So I don't like to waste my time. So let's move to others part. The part is when we take the value, the force vertical by vertical direction. Okay, the next part, same steps, don't worry. Here the force 1 kilonewton assumed. Okay, we have also here 2 reactions and here 1 reaction. This is node number 1, 2, 3, 4. So take the whole to find the reactions. This is VB, VA, HA. So summation FH equals 0. It will be 0 because we have only HA 0 because we don't have any forces on horizontal direction. Take its summation forces by vertical direction. VA equal VA minus 1 equals 0, so VA equal 1. So next step, we find the internal forces for this figure. Node number 1. Node number 1, we have, sorry, what happened? We have only the reaction and the internal forces. The internal forces, we have 1 and 1 4 is 0 because we don't have any horizontal force in this part. So, and we have only n 1 2. So this is easy, just direct solution. Plus 1 equals 0 and 1 2 equal minus 1. The node number 2 we have 3 and 401 kilonewton, and 23 and 24 and 12. This is equal 1 as we find it, this value. Okay, and this is the alpha. Same steps like I done before. So here in this example we will get, after you find the sine and cosine of alpha, you will get the summation fv equals 0, so that n24 equal 0, and you can check the others part. All the others members are equal 0. So go to the next. Next is the release system, X system. Here we have 1 and here we have 1. So to make it easy for you, here I will assume that the value, the angle is here, theta, sorry, alpha. So this one, it will be 1 sine theta, 1 cosine theta, 1 sine theta, and 1 cosine theta. The reactions, we have 1 here and 2 at node. So then take it the moment around rolling. This is joint number 4 equals 0. v1 times 3 plus 1 sine theta times 3 minus 1 cosine theta times 4 equal 0. v1 equal minus 3 sine theta plus 4 cosine theta over 3 equal 0. Then tan theta equal 4 over 3. The theta equal 53.13 degree, and the sine theta equal 0.8 and cosine theta equal 0.6. So then substitute the values, and now we're going to find the internal forces for this system. Node number 1. Node number 1, we have 3 parts or 3 members. N14. This is 1, force 1, as we assumed after we release the member F, we assumed 1, and this is N12. So summation FH equals 0, N14 plus 1 cosine theta equals 0, N14 equal minus 0.6. Minus, that means compression. Okay. Then summation FV equals 0, N12 plus 1 sine theta equals 0, N12 equal minus 0.8. This is also compression. Then then go to node number 2. This is n24, n23. This is 0.8, this value. Okay. Tan equal 3/4. So now summation FV equals 0. N24 cosine theta minus 0.8 equals 0. N24 equal 0.8, 0.8 equal 1. And here n node 23 plus node 24 sine theta equal 0. So n23 equal minus 0.6. Next, go to other parts. Node here will not will be 0 because we have inclined force, sorry, one force. So it will be like this. I put it in this direction because it's positive. Okay, and the angle is here. So n34 plus 1 sine alpha equals 0. N34 equal minus 0.8. Yeah, this is enough because the node number 4 is same previous. It's the same previous node number 2 because same location. Okay, not same location. I mean, it look like same steps with node number 2, but I just solved this one because to make sure how we can solve this joint if we have 1 kilonewton, because we already our figure is look like this. Okay, and because we have 1 degree, that's been indeterminate, so we should release or remove one part or one members. Okay, for me I remove this part. Okay, and assumed we have here force 1 kilonewton and here 1 kilonewton. So it's actually normal solution. Don't worry, it's not make it difficult or something dangerous. Okay, just to show you how we can deal with this part of examples. Okay, next for the f equal tr time r plus tx time x. So here we can't remove this part. This part cannot remove as like previous video. The r is the reactions applied on the shape or in the figure. We have 0.5 and 1. Okay, you can check the original figure or the first figure. For tr we have here 2, tr1 and tr2. This is get from internal forces For TR1 1.33 001 minus 1.676, sorry, 67. And the last one, that the member that we removed it and assumed we have 1 kilonewton, we will put 0 because we don't have any value, it's already removed. And when we solve, this is our figure. Okay, I remove this one. Okay, when I remove it, I should substitute 0 here. Okay, then here minus 1 0 0 0 0 0. You can go to the previous video and you check how can I put these values for TR. Okay, for TX, this one, TX we have 1 because we removed one part or one member. Maybe next example I will show you how we can, if we remove 2 parts. Okay, so TX equal minus 0.8 minus 0.6 minus 0.8 minus 0.611. You can recheck again this value, how we can calculate it. Okay, here because we assumed is 1. Okay, then just substitute these values in this equation. So now we just we have only one part. One part is the x, this one. Need to remove some. This one we don't have the value of x. Okay, so let's go to show how we can solve this one. The displacement is, during displacement, delta x, here kx, krr, krx, kxr, kxx, and this is the r, this is x. Okay, so for each one of krr, let me to write the rule. Tr inverse time f time tr. krx equal tr inverse time f time tx. kxr equal tx inverse time f time tr. kxx equal tx inverse time f time tx. So f here, so tr is okay, we already find it, and just make it inverse. Tx already find it from the internal forces. This is from R system and this is from X system. Okay, so for F value, it's the length of each member. So F for this example equal AE matrix, the length of A, member A, length of B, length of C, length of D, length of E, length of F. And the other element is 0. it because we wrote this value like incline cells because we have a matrix. Okay, so cannot make it a vertical or horizontal. So now for first you should solve or find each value for this matrix, depend on these rules. Find KRR, KRX, KXR, KXX. Finally, after you solve it, just okay, I can solve for you. Some references, okay, KRR, some references called like this F node or F dash RR. It's okay, no problem. It's same rule or same steps. TR inverse F TR. So the TR inverse 1.33001 minus 1.670 minus 1.00000 time the F values. F value is 43435. 5 is square root theory of Pythagoras equal 5. Time the TR is 1.33 minus 1 001 minus 1.670. Here 0 all fit 0. Okay, same steps, or let me same steps you can find for KXR, KXX. So finally, for the X value, I want also to find or to know how we can find the X. The X is equal minus K. I don't like to make it confuse because I have two references. Minus FX. Sorry, I'm very sorry, guys. Sorry. Minus KXX inverse, or to minus 1, yeah, inverse, and time KXR time R. From this rule you can find the X value. R is the forces that applied on our structure. We have 0.5 and 1. Kx you can find from this root 1, and the kxx, but just make it inverse, you can find also from this one. Okay, and then substitute your values and you will get the value of x. Beside that, so here this is the value. Let me to write the value for you and you can check by your own. Minus AE over 17.28 minus 14.4 and 3.2. This is two columns. Be careful, this is because it's a matrix. Two columns, it mean 1 times 2. Okay, this is the value, the result of x. Next, you should find the displacement. Displacement equal from this rule k r k rx k xr and k xx rx. Then here it will be 0 because the forces is assumed force, it's not a real force, so equal 0. And finally the delta equal krr minus krx times kxx inverse k xr. This is time r. Here. So finally, or you can write in another way, k time r. Okay, because here is 0, so x no need is 0. I will give you the results of delta equal 1 over AE. The matrix we have 2 times 1, that's mean 3.333 and 2.074. This is on x direction and this is on y direction. This is AY, delta AY, and this is delta AX. So guys, thank you so much for your kindly watching and listening. See you in the next example.